We, the students of Chandigarh College of Engineering and Technology, are hereby to present our project entitled SNIFFER BOT, made exclusively for the participation in TI India Analog Design Contest 2012-2013. As the name of our project suggests, our SNIFFER bot is mainly used in military purposes for detecting mine and spying purposes. We would also like to thank Mr. C.P. Ravikumar and Mr. Sagar Juneja for organizing this event. I would also like to acknowledge our HOD ECE department, Mrs. Sarita Sharma, and our faculty member, Ms. Shivani Goyal, for their invaluable help. I would also like to thank my friends who helped us throughout this project. Now let us have a look at the components used in making this sniffer bot.
Himanshu.
Now, this is the mobile part of our project, the sniffer board, and this is the control system which is used to operate the sniffer board. Now, first of all, I would like to explain the sniffing part, that is the metal sensor part of our project. Now see, this is the metal sensor which senses the metal and gives its output to the LED, which responds accordingly. When a metal is detected, the LED glows, and when LED glows for a short time, and after that it's switched off. Now first of all, I would like to explain the chips used by us, manufactured by the TI. Now, first of all, the L293D, that is the motor driver IC, which drives the motor by increasing the current. The second one is the voltage regulators, that is the 7805 and 7812. Next one is the op-amps, that is the comparator LM324 IC used with the metal sensor, and also the ULN2803, the Darlington pair. Now, coming to the different sections of the project. Now, these are the different sections. First of all, the power supply section, from where we get the power supply for all the sections. Now see, the laptop is an essential part for our project. See, there is a software BitVoicer installed in the laptop which recognizes our voice commands and sends the corresponding data to the USB port. Data from the USB port is converted in serial form by USB to serial converter. Now this serially converted data is fed to the input of the PIC microcontroller's serial port. Now for the interfacing of PIC microcontroller with the RS232, we have used MAX232. What this MAX232 does is it makes the voltage level of the PIC microcontroller and the RS232 compatible with each other. Now the output of the PIC, that is from the port B of the PIC, is sent to the encoder part. Now the encoder is something which encodes the data from the voice commands in some particular format and gives it to the transmitter in serial form for the transmission to the sniffer board. Now, as the data is received by the receiver fixed at the sniffer board, the receiver gives this data to the decoder, which decodes the data in its original form as was sent by the PIC microcontroller and gives it to the AVR microcontroller. Now, the AVR microcontroller responds accordingly to the program burnt by using the code vision AVR for the different input combinations and gives its output at port A. Now, this output port A is connected to the motor driver ICs, which I have already told used to increase the current and helps driving the motors. These L293D ICs are used to drive the motors. Now I would like to explain.
Now I would demonstrate how the different voice commands are sent to the laptop and how the sniffer board receives them and responds accordingly. Now see, this is the mic used and is connected to the laptop. Now see, this is the window of the BitVoicer software. See, this is the start button, and as I click, the software starts responding to my voice commands. Now, the different voice codes used are A, Z, Y and X.
Now the different code words are 6, 9, 7 and 8 respectively. Now according to these code words and according to the program burnt in the PIC microcontroller, the commands are sent to the sniffer board. Now see how the commands are sent. For the forward motion of the board, command A is sent. See, A. Now see, this A is recognized. A. Now for the backward movement, command Z is sent. Z. Z. Now see, and similarly the different commands for the left, right and other movements of the board are recognized. Now we would have a look at the working demonstration of the sniffer board.
Now we will show the various movements of sniffer board. Z. Now we will show the left movement of sniffer board. X. Now there will be a demonstration of the right movement of sniffer board. Y. Now we will show the backward movement of the robot. Z. As you can see.
Now we will demonstrate how our sniffer bot operates in the warfare arena to detect a mine. As you can see, our sniffer bot moves in the forward direction, and when the mine comes, it detects the mine and LED glows. As you can see, the LED glows after detecting the mine. Now the glowing LED can be viewed on the screen of the operator, and the operator can give directions to the sniffer bot accordingly. Here you can see the mine is detected and the LED is glowing, and our sniffer bot is moving in the forward direction after detecting the mine.
This was all about the operation of our project sniffer bot. At the end, I would like to thank Almighty God and our worthy parents. I would also express my deep sense of gratitude towards Texas Instruments and Mr. C.P. Ravikumar and Mr. Sagar Juneja who organized this talent showcasing event. I would also like to thank our faculty member Ms. Shivani Goyal and our HOD ECE department Mrs. Sarita Sharma. I would also like to thank my friends who helped me at every possible step. Thank you.